partial pressure versus vapor pressure. So what's the difference? How can you identify them? And are there cases in which partial pressure equals vapor pressure? Well, this is what we're going to see here. So before we actually continue, or before I tell you what's the difference, please try to solve these three questions. Are partial pressure and vapor pressure the same concept? Can they be equal numerically speaking? I mean, for instance, partial pressure is 1 atmosphere. Can we have vapor pressure to be 1 atmosphere? And how to differ between them? Okay. So click pause and solve it for yourself. And once that you think you know, click play. And I'm going to assume that you paused and that you have now your answers. And let's see. Well, are partial pressure and vapor pressure the same concept? No. No, they are not. Actually, partial pressure depends on the total amount of pressure exerted by gas A, whereas vapor pressure depends on the equilibrium conditions, that is the temperature, the concentration, and so on. So partial pressure does not depend on temperature, and vapor pressure will depend on temperature. So typically they are related, but they can't always be the same. So talking about the same, yes, they can be numerically equal. So for instance, let's select water. Water, let's say, that has a vapor pressure of 1 atmosphere, given it is at 100 Celsius. And let's assume that this gas is at 100 Celsius. Now this is vapor pressure. Now, in order to obtain partial pressure of water to be 1 atmosphere, let's say we have 2 gases. Both are the same conditions. So we have the pressure of 2 atmospheres. And since this is 50-50, so let's say half is air and the other one maybe, I don't know, let's guess it's methane. So therefore the partial pressure of our water vapor will be equal to the half, because it is 50-50, so this is a molar fraction, times the total pressure, which is equal to 1 atmosphere. So technically speaking, and let's assume this is at 100 Celsius, technically speaking, we have this specific case or unique case in which partial pressure equals vapor pressure. Now, if we will have only 1 atmosphere in the total system, then we will have 0.5 atmospheres, and then we will not have this case. So in general, let's assume that it's kind of hard or a coincidence that the partial pressure equals the vapor pressure, but they can be the same. How to differ them? Well, one will depend on the total parts or total amount of composition of the gas, and the other one will depend on the unique conditions of that pure substance. So let it be that if partial pressure equals X, vapor pressure will have its unique Y vapor pressure at the given temperature. And actually you can check this on tables, whereas the partial pressure will be an experimental value.